Hello to you all. Thank you for stopping by my presentation. My name is Taylor Gamble, and today I will be presenting the research that my colleagues and I have been conducting in order to make allynes through an allylic diazene rearrangement of alkynyl hydrazones. I'd first like to start off by giving an overview of what allynes are used for and why they're important. And so allynes are an available center axis for chirality transfer. They are also useful as electrophiles and nucleophiles. They are contained in many natural products, and they serve as highly functional building blocks for the synthesis of many complex molecules. And so the following are just an array of different syntheses and reactions that allynes have been used in. And so we have the cycloaddition reaction, which is based upon a Diels-Alder reaction. And then we also have the oxidation oxotransfer. We have the transition metal catalyzed addition to allynes, and we have the metal mediated ionic reactions. So the plan here is to make the allynes from an allylic diazene rearrangement. And this will be derived from the hydrazone that are made from the ynones that will come from our starting material, which is the S-methylactate. And just to give a few positives about the research that we're doing, the starting material that we have is very inexpensive, and so it's easily accessible. And then we also have common reactions taught in undergraduate lab. So our research coincides with our studies, which only further deepens our understanding of what we're doing here. Our research also does not require elaborate equipment or inert conditions, and it contains alpha hydroxy groups for further elaboration. In order to synthesize these allynes, we first needed to synthesize a wine-rib amide. And in order to do that, we started off with our starting material, and we focused in on the methyl ester. And we added silver oxide followed by benzyl bromide, which protected the alcohol group, and it was done in diachloromethane. And we let that sit for about 48 hours, and after 48 hours we filtered the silver oxide through saponification of the ester with sodium hydroxide and ethanol. This was then followed by HCl to protonate the carboxylate. From this step, we had to turn the carboxylic acid into our wine-rib amide. And in order to do that, we used mesyl chloride as an activating group. We then added the amine and the triethylamine, which acted as the weak base, and the diachloromethane once again, which acted as the solvent. Our next step is to form an inone through a Grignard addition. And it's important to note that our wine-rib amide further functionalized our molecule in that it formed a metal chelated intermediate. And this intermediate was stable enough to prevent the over-addition or over-alkylation of our molecule. This is as far as we've gone experimentally, but the following slides will be our steps moving forward. So we are looking to form the inone with varying substrates on our Grignard reagent. And we want to do this, we want to build this library that varies in sterics and electronics because we want to test the reactions of different substrates and their effect on the reaction. And the following are different substrates that we would like to test in the near future. The next step is to form the hydrazones, and we believe that we can accomplish this through the use of tosyl hydrazine under microwave conditions. And what this does is attack the carbonyl to form hydrazone. And because we are following similar procedures as the Macintosh group, we believe that the E formation will be favored. And this is supported by the transition state depicted in number 17, which participates in hydrogen bonding, thus allowing for the formation of the E hydrazone. Finally, we need to commence our allylic diazene rearrangement. And in order to achieve this, we take our newly formed hydrazone with the tosyl hydrazine and add in a reducing agent such as sodium cyanoborohydride. And this will form our alkyl hydrazine. This is then heated to execute the ADR, also known as the allylic diazene rearrangement. Once this is done, our allyne will be formed. Lastly, I'd like to thank everyone who allowed for this research to happen, as well as allowed me to participate in this expo today. I'd also like to thank my fellow researchers, Lauren and Micaiah, as well as my mentor, Dr. Walker. And thank you as well for listening to my presentation, and I hope you enjoyed.